VIT Mathematical Association presents to you integral insights through MATLAB.
Hello guys, I am Shoumik Adhikary, a first year undergraduate at Vellore Institute of Technology in Electronics and Communication branch. Welcome to Integral Insights. In this module, we'll be looking at application of MATLAB in order to solve questions of integration. Basically, before we even get into the code, into how integration in MATLAB works, we need to understand our primary motivation for studying MATLAB. Now, a scientific computing language. This means that it is used often for scientific as well as mathematical calculations. MATLAB was developed by Cleve Muller in the 1970s and it's written in C and Fortran. He made it because he felt that there should be an easier way for students to do matrix calculation, especially of higher order matrices such as 3 into 3 or 4 into 4 matrices. So, as engineering students, we need to understand MATLAB not only as a programming language but as a scientific language. I think MATLAB is very misunderstood because a lot of people were thrown into MATLAB during a calculus course and they could not understand the code correctly. They could not explain it correctly. However, you do not need to worry. I am here. I will explain you each and every line of code and how MATLAB works. Okay, so let's get started. First of all, we know that area between any two functions f of x and g can be represented as a equal to integral from b to a f of x minus g of x. Now this b to a is the limits of x where the function extends. This limit can be obtained by equating f of x and g of x. So it's not really that tough of a concept, I think. Now we also know that in terms of y it can be rewritten in the following manner. Now let's get to the code directly without wasting much time. Starting with, you should always do this. This is called CLC. This clears the command window of any previous code that was left behind or the outputs of any previous code including error messages. And then you're supposed to do clear all. Basically what this does is it clears the workspace of any stored variables. Generally, if variables are stored in the workspace, they need to be cleared up before another program could be run. Now, simsx we'll have to do y as well actually, but let's stick to x first. Sims means symbolic calculation. You know how modern calculators like any Casio calculators that you might buy at a store, which can do basic integration, differentiation, quadratic equations, anything, it might not have CES functionality. CES is symbolic functionality which allows computer to assign a symbol, that is x, y or z or any variable which is unknown, into the function. MATLAB has CS functionality and this simsx, this is symbolic. It is used to declare that the variable x is symbolic within our program. Now, let's define a function f of x equal to input. This input is used to give any the program. Basically, we want to define f of x as any input. Like first we'll take x cube, but let us now put this input, and inside the string of the input we can write whatever we want to. Like basically here I'm going to write enter the function in the form f of x. Basically this is indication. You can leave it as input only, like similar to this. You can leave it as this also, but I think it would be much easier to understand if you put the string here so that you know what you're doing. Now let's take another function g of x as input. Enter the function g of x. Now, notice how we discussed that integration is area between any two functions f of x and g of x. We are defining those two f of x and g of x as the user input here. Now, let us take L. This L will be the limit under which area is defined. In MATLAB, we cannot just integrate it between any two. Like we can, but obviously we'll need to make the code more versatile. So let's take input. Enter the function in the form a comma b. Now these a comma b are the limits of integration obviously, but it should be noted that it will always be in this form. This means that it should be in the closed bracket with two limits. Like let's say this area between x cube and x square, we'll find that the common limits are 0 and 1, right? So we describe this as 0, 1 like that. Okay, so I guess that much. Now let's define a, or the lower limit of integration. A will be equal to L of 1. Basically L of 1 means that from the limit L, Like, let's say L is any limit 0, 1. We are taking 0. We are taking the lower limit basically. Similarly, let us define B as L of 2. Now this is taking the upper limit. Now AR or area equal to int. Now this int is a function which is of the form int f of x ab. This basically means that you are integrating f of x with respect to x from a to b. Now here we are not integrating x, we are integrating f of x minus g of x with respect to x from a to b. Now we have the area as a separate stored variable whose answer is int f of x minus g of x with respect to x from a to b. Now first let us display area. And let's see if this code runs. Yeah, here it asks us for f of x. So let's put x square. G of x cube. Now we know the common area between them lies between 0 to 1. So we'll put the limit L as 0 to 1. And it gives us the answer 1 by 12, which is the correct answer. You can try it with an integral calculator. So I think we understand how to integrate between any two given functions x and g of x with respect to x, given that we know the common range in which they lie. However, this is not the part where most people face problems. The part where most people face problems is in plotting. Now, in plotting, the people generally seem to forget that this plot function, it doesn't work like matplotlib or the plot function in R. It behaves differently. Basically, you cannot plot f of x. You will see if you do plot of f of x, it will return you an error. This is because it accepts data in the form of linspace. Now, what is linspace? Linspace is a discretized point. Basically, it cannot take f of x for all variables. It will need two ranges between which it takes f of x. Like, let's say x1. Let us define a new variable x1 as linspace a, b, 100. This basically means that we are taking 100 lines between a to b. That is 100 lines between 0 to 1 which are being discretized. Basically, f of x is now not defined as a function which has a symbolic variable x. It is defined as a function as a symbolic variable x which exists in the 100 lines between a to b which we have just discretized. So we'll take a y1 f x x1. This sub basically means that we are substituting x with x1, like we are replacing x with the 100 lines between a and b. Now let's take another x2. x2 will be equal to x1. However, y2. This y2 will be subs gx x1 or gx x2. You will get the same result either way. Basically, what we are doing is for the first one, x1 and y1, we substituted fx with fx1. This is the 100 lines between a and b. x2 we kept the same, so because the range of limit of x2 will always be 0 to 1. However, for y2 we substituted a different function g of x. Now this will make sense, trust me. Now when we do plot of x1 comma y1, let's try this first. Okay, so yeah, x cube x square L 0, 1. Yeah, ignore the answer because I put x cube twice, but you'll notice that we now have a function of f of x. Now x is from 0 to 1 and y is from 0 to 1, obviously, but you'll notice that x1 comma y1 only plots this first graph. It cannot plot the second graph until we give it to it. However, we need to notice that we cannot plot both of them simultaneously. We'll need to hold on. Now what this hold on function does is it stops the plotting in between so that we can put other graph attributes such as x label, y label, the second plot, legend, etc. grid into the graph before we let it plot. Now plot x2 comma y2 and grid on. Now what this grid on does is it basically gives a grid to the function. You might have noticed that a lot of actual, like real life graphs, the ones that you draw on graph paper, have grids between them. Basically this grid on gives the grid, and x label, this is basically the label on x axis, which is x axis, or you can put it anything, doesn't really matter, but I'm putting x axis and y axis because for obvious reasons, and hold off. Okay, now let's run this. x square. X square first function, x cube second function, 0, 1, the limit between them. Yeah, beautiful. Now we have the entire graph with respect to the x-axis, with respect to the y-axis and the grid, and both the functions f of x, comma g of x. However, you might realize that obviously we can realize that the upper curve is x square and the lower curve is x cube. However, if you want to make the graph look better, like make it look more presentable, you're supposed to put this legend f of x, comma, a bit smaller there, f of x, comma g of x. Basically, this will introduce a legend which will allow us to see the order in which these functions occur. Let's run this. Right. Same function x square, x cube, 0, 1. Beautiful. See, here you can clearly see f of x and g of x. You can see that the blue line, the upper curve is f of x, and the orange line, the lower one, is g of x. Here we can successfully say that we have determined the area under the curve through integration through MATLAB. However, this is not complete yet. We need to look at another form of it, and then we'll move to some examples. Now, let me clear it. Let's look at area under the curve, under a single curve. This will probably be the same thing as the older one. However, the plotting will have a very small slight difference. This won't change a lot of the code. Like CLC, this one we know. We need to clear the workspace because it still has the old code in it. Clear all. Clear the stored variables in MATLAB. That's evident, I think. And f of x equal to input. Enter the function f of x. This allows us to enter the function in the form of f of x. Obviously, we discussed this. This is called the input function. L. Input. Enter the limits. It's the form a comma b. Also, it's a general rule of thumb, but you should write what kind of data type this should be entered in, because your side it makes sense, but client side, if let's say you're at a very big firm and you have to write this code, you have it as user friendly as possible so that they understand what's going on basically. Now, obviously, we are going to do the same thing. We'll define the lower limit a L of 1, b L of 2. These are the two limits given the range a comma b, right? Area equal to int f of x with respect to x, a and b, with respect and the area of the function with respect to x from a to b, which is what we discussed, right? So that will be the area. Now, oh, we almost forgot one thing. Sims x. If we don't declare the symbolic variables, none of this will make sense to the computer because it does not know what x is. When we declare a symbolic variable x, it understands that x is a symbolic variable which is not defined, like currently not defined. Now, this will work obviously not. Yeah, I almost forgot this. Yeah. Like x square 0, 1. That's a common mistake, but if you don't disp nothing, you get an answer. So either use disp area, or what you can do is remove the semicolon. The semicolon is basically what this semicolon does is it hides your input in the code. If you remove all the semicolons, then the command window will be very messed up because it will show you each and every variable that's stored in the form of a matrix, obviously. So, like there is no semicolon here. So if you do x square, x cube, 0, 1, it shows the answer. Area equal to 1 by 4. So you could do this, or you could do disp area. Disp is basically the equivalent of the print function or the system.out.println or whatever is the equivalent in your native programming language in MATLAB. Also, if it's a changing variable, you're supposed to use character, but generally this isn't required. For this code, it isn't required. The plotting is the main part of this. in plotting, what you're supposed to do is, let's take x1 as length space a comma b comma 100. Now a comma b comma 100 means that there are 100 points between a and b, right? And y1 equal to subs f x x1. This is not that hard, but don't take any x2, don't take any y2. We just need to plot a single function. Now plot x1 comma y1. Plot x1 comma y1. Hold on, though it isn't required in this one, so we could just get rid of that. Plot x1 comma y1. Grid on x level, x axis, y level, axis. Other than that, legend f of x, g of x. We don't need g of x. It isn't here. Now let's just run this. Let's take a much more different function, x square plus 3x plus 2 from -2 to 1, right? 9 by 2. Let's look at the plot. There we go. So this is the plot of the function with respect to the x and y axis, and obviously we already have the legend. There's only one variable. Some further insights on this. If you reduce the number of length space from a to b, we took 100, right? Let's take 50. Then you'll notice two things. Let's take x square for this one, x cube for this one. Either way, same thing. 0, 1. You will so basically, if you reduce the number of discretized points, you will notice two things. First, the upper function and minus x lower function, and or the opposite, minus x upper function and 2 minus x square lower function, you'll get the same result. That is to say, you'll get the same result, but the sign will be negative, but the integration will pretty much be the same, just with the negative sign. Okay, so let's take f of x equal to minus x square and g of x equal to minus x. Let us define the limits. L equal to -1 to 2, a equal to L of 1, b equal to L of 2, and area equal to integral f of x minus g of x x a b. Beautiful. Now display area. Also remember, this thing is case sensitive, so if you write area, it won't give you anything because it does not know what small area is. It knows what capital AREA is. Beautiful. 9 by 2. That's our answer. You can check it by an integral calculator if you want. Now to plot it, x1 equal to length space f length space a comma b comma, let's take 50, less computational time obviously. y1 equal to subs f x x1, simple. x2 equal to x1, y2 equal to subs g x x1, right? Plot, we are just going to plot, we are not going to give y level, x level and all that. Like, it is considered under good principle to do that, but we are having a look at a lot of problems right now, not just this one. By 2 and figure 1. Yeah, this is the graph that we obtain. Obviously, you can get an x-axis here, y-axis here, a legend, a grid to make it look pretty, but I mean, you get it. It's not needed at this point. Now let us look at another exercise question. Area under the curve y equal to x square between x equal to 0 and x equal to 4. Now here you will notice that it's in the form of y, not x. So you are supposed to integrate with respect to y. Like, x limits are given 0 to 4. Take the y to the other side, you will obtain that x square equal to y minus 1 and x equal to under root y minus 1. So basically we just have to integrate under root y minus 1. So f of, let's change sims x to sims y, f of y equal to square root, this is sqrt is the function in MATLAB for square root y minus 1. Beautiful. limit 0 comma 4, write the limit in x, not y, and the x-axis. Yeah, and area equal to int f of y. Also, we forgot one thing: a equal to L of 1, b equal to L of 2, y a comma b. This area. Yeah, and this is our answer. However, I am not sure it is correct because it's showing an imaginary variable. Okay, let's move on to the exercises. Now, first exercise: find the area of the region bounded by the curve y equal to x square minus 2x and y equal to x. Now, x square minus 2x equal to x. Also, if you don't feel like solving these, there is one way to solve it using the solve function. I will not show it in this video, but basically you don't need to manually solve this if you want. However, this is not that tough of a computation to do. X square minus 2x equal to x. So x square x equal to x square equal to 3x. X is from 0 to 3. Basically, it's just the same code as every last one. Is that one? Yeah. Let's we know the limit is 0 to 3, so first we will replace the limit with 0 to 3. F of x is x square minus 2x and y equal to x. So x square minus 2x. Also 2 star x, not 2x. 2x won't fly. 2 star x, it only understands 2 star x. If you write 2x, it will think that's a new variable. X square minus 2x to x. X f of x minus g of x 0 to 3. It's fine, I guess. Now look at the answer minus 9 by 2, which means that our original assumption is wrong. X is the greater function, x square minus 2x is the lower function. So let's change that actually. Otherwise the graph might come out wrong. X square minus 2 star x. Nine by 2, which is the correct answer. Also, forgot to close this. And this is the graph that we shall look. Okay. Yeah. One more thing. Don't ever keep the same plot while running an old plot. Basically, if you're using an old plot, just remove it from the taskbar over here. Otherwise, the two plots will overlap. And there's no way to avoid it other than running the code again. Okay. Yeah, I think this is the correct figure. This is the figure we are hoping for, not that one. And let's look at one more example, right? X equal to y cube and x equal to y square. So y cube and y square. So instead of sims x, use sims y. F of y, function of y is y square, and the second function of y is y cube, basically. And we know the limits between the two are 0 and 1. On the plotting f of y minus g of y with respect to y, it's not with respect to x anymore. And this area, that's fine. Instead of x1, you can take y1 if you want. Basically, the that you will get otherwise might be flipped. Like, let's take y1 as linspace a comma b comma 50, x1 as subs f y1, and y2 equal to y1 and x2 equal to subs g y1. And let's put the grid on so that it looks nice. X label, x axis, y label, y axis, grid on legend, f of y, g of y. Let's run this. Also, yeah, close the figure. I think it might be a bit too late to do that. Let's run it again. Yeah, there we go. That's the figure we're looking for. If we took x1 in place of y1, this figure would be flipped with respect to this. It would come out as this, not this. However, it's almost this. Like, it's not the same thing, obviously. one is an upper parabola, one is a lower parabola. Generally look at the variables and look at what you have to take symbolic. It will be either x or y. And if the question gives it in such a way that x equal to y cube and x equal to y square, take f of y and take sims y. If it gives y equal to x square minus 2x, y equal to x, take f of x, take sims x. I think that concludes our discussion on this topic. I hope you enjoyed it, and I hope you gained some insight on how to use MATLAB from this. MATLAB is very largely misunderstood because it's one of the easiest programming languages to learn if you know what you're doing. And I hope this video series by VIT Mathematical Association keeps you engaged in this content. And that's all, I guess. Thank you.